just wanted to take an interlude here to give you a real life story of testing in the real world. And this has happened to me not many years ago now, a couple of years ago. And I was trying to implement a solution at a customer. And they were suffering in an environment where they had multiple test environments, dev, pre-prod, UAT testing, about 6 environments that they had, but they weren't enough. They weren't able to test and implement all their IT initiatives. They had multiple databases that made up a single system, and they were different types of databases, and that was complex to synchronize. They had an application vendor that was delivering their core application, and they could only fix forward. So whenever they took a new upgrade of that application, it had to work, or they had to work through the clock to get that application fixed and resolved if there were any problems in production. Often because of the testing and the slowness of the testing, a lack of environments, products came late to market. Marketing budget got wasted when they were advertising features that they didn't have. Production faults when they didn't test well enough meant that they potentially lost revenue, lost customers. And also it was interesting during this time of doing this implementation, the database size increased from about 9 terabytes up to about 30 terabytes. They did manage to sort out the archiving, but it was a massive growth in data. And I talk about this. So this was probably me, but project manager's anguish, or the test manager's anguish, really, because all we wanted to do was start the project. But what were the problems? We realized that their existing infrastructure was stretched. They didn't have enough infrastructure. We attempted to do something by the back door, cannibalizing servers, trying to implement a system, but it was too risky. But the cost of putting new systems in place, getting some new infrastructure, meant that there was going to be a 6-month delay. So the whole thing just slowed down for 6 months whilst they organized the budget. We managed to get the budget approved, the environments were built, but they created the wrong operating system. And then they had production issues, which delayed delayed whilst they corrected the production problems. So the project got delayed by 2 weeks. That took us into Easter holidays. Staff were unavailable. Were we going to wait, or do we keep going? We decided to keep going, so we proceeded with limited staff. The environment therefore got wrongly configured. We had to reconfigure the environment. Additional delays. We went in one day, drove all the way to the site, only to be turned back where they said, "Oh, we've got production issues. All of our staff are working on the production issue." So again, further delays. And that continued, right? So we got the infrastructure in place. We're all ready to go. Let's finish the job. But then we realized we couldn't connect to production. The security team wouldn't let us touch production. They had to locate and cannibalize an obsolete server. We had a storage net and network weren't to specification. We had no exclusive use of the target environment that we'd created. So because we'd delayed, we went into Easter, but we also went into month end, and they were doing month end testing. We dropped a database onto their month end testing machine, and we blew up their month end testing. They weren't best pleased. They told us not to touch that thing. We had to cannibalize another server. That was on the wrong environment. The masking job that they had was primitive. Key personnel were unavailable for testing. And when we finally went to do the testing, the databases weren't synchronized, and the guy was almost about to step out of the door. So they're real problems, right? So how do you achieve velocity in all of that? Well, first of all, you need to think about people and processes as well as the technology. And the process includes sort of DevOps, but really it's around the data that backs that DevOps capability. And if you look at those tech giants that we talked about, what they have done is taken an engineering mindset, and they keep tuning for speed and eliminating wasted cycles. So what you're looking to do is remove the bottlenecks and to keep the machinery running until you go to the next bottleneck. And one of the biggest bottlenecks at the moment is access to data. So how do you handle that? What do you need to do to solve the data problem, if indeed that's what you have? And certainly that's what I see across a number of organizations. So what we believe you need to be able to do is to provide a programmable data service. So first of all, a data service that first of all simplifies access to all of that data. So you need to be able to get data in whatever source that data is, whether it's an Oracle database, SQL Server database, Sybase, DB2, NoSQL database, Couchbase, MongoDB, whatever that data is, you need to see a simple front-end copy to that data. It needs to be homogenized into an environment where you can uniformly process the data. So it needs to be on all sources, and we need to operate in all cloud environments as well. We need to be able to protect that data. So you need a tool that's going to de-identify the data, to protect the data, to meet those regulations. We need to be able to also version control that data. So we need sets of data that we can use at specific points in time for projects where not only the application has changed, but the source of the data, the structure of the data may have changed as well. So we need to keep that versioning in place for the data. We talk about immutability. So we need to ensure that the data is in the same format, or we can return to the same format of the data, not only for testing and retesting purposes, but also that immutability is quite important these days in order to validate your backups, to make sure you're protecting yourself from the kind of attacks like ransomware attacks, where you're sure that you're backing up the data that you expect to be backing up and not data that has been compromised in any way. And also there's that idea of the utility of data. So providing the data in the right form to enable specific use cases. So it's got to be the right size, the right scale, it's got to be fresh, it has to have referential integrity. And for analytics, that means that it's current and historical and all the features are preserved. So you may have to de-identify the data in specific ways for specific purposes. And then also, it's got to be space efficient, because that data is monstrously huge already. And so what you want to be able to do is to somehow access that data, copy that data in a way that allows you to create multiple copies that are efficient and also agile. And then on top of that, all of that capability, we need all of that to be driven via a straightforward API that allows us to integrate effectively in the existing processes, whether they are DevOps processes, CI/CD pipelines, or production, root cause analytics, application performance management environments where we're delivering data automatically and very quickly. So one of the big things that I see is the ability to self-serve data really drives at the heart of what we need to do from a test perspective. Because a lot of the time we want, if you can give me the data now that I can test with, and give me specific data, I want data from this point in time and I need it now. And you want to get all of the data, that's data synchronized across the multiple databases that create those end-to-end systems. And this is really imperative, let me break it. And let me break it without fear, because as soon as you can break things without fear, then you get effective and proper testing. But also you drive innovation, because a lot of the time, if you've got something that is going to take you a day to recover or a week to recover, then you're pretty loath to go into that system and start to test it properly, start to break it. So, but if you can recover very, very quickly, then that spawns innovation. You can start to look inside of the data. You can start to do things that you wouldn't necessarily do. And so what that brings us to is this self-service. So if you look at provisioning and refreshing environments, if you have to go to a DBA or an IT team to get that data, and there's a ticketing process in place, immediately you've slowed yourself down. You're not going to move very quickly. So that needs to be automated, and ideally it needs to be self-service, so that either you or a machine image of you, an automated copy of you, can actually get that data at a point in time that they need. That integration testing allows us, so you want multiple data sources to be synchronized in that self-service environment. And when it comes to destructive testing, you need to be able to recover those environments very, very quickly and in a self-service manner. And so what the product that Delphix provides, this programmable data infrastructure, provides this self-service capability, which is quite powerful. So we actually are able to deliver multiple terabytes of data in just a few minutes. And just last week, I was testing an environment. We were taking it was about 4 terabyte database, and what we were trying to do is look at masking, de-identifying that database. And obviously, a masking process tends to be a development process. It's an iterative process. And it was quite interesting. That 4 terabytes of data took me about 5 hours to get into the Delphix system. But once in there, we were able to provision a copy in 96 seconds. So in under 2 minutes, we got a copy of that 4 terabyte database, which was great. And now I was able to start masking that database. But when I first started masking it, I set the indexes wrong, and it was running for 17 hours, and it was clearly broken. So I had to stop that process and start it again. But if you can imagine that, I've now got a half-masked set of rows of data, half-masked column. So I actually needed to restore that database. And pressing a button in the self-service interface allowed me to restore that database in just 2 minutes. So now I've gone back to the original version, set the indexes right, and the job ran in 3 hours. We did a few iterations around that, 2-minute iterations, did some changes, and we were able to increase the speed of that masking from the original 17 hours down to 3 hours, down to 19 minutes. And all of that was in the space of a day and a half. So if we'd have had to wait 5 hours each time to iterate that database, that would have taken at least 3-4 days. And we've reduced that down to a very small period of time. And now we're able to not only test more, but we can stretch the boundaries a little bit more. We can do the what if we change this index? What if we create a new view? What if we remove the triggers? What if we only remove one trigger? And so all of that processing was able to be done in a much shorter space of time. Not only that, because in that self-service environment, we're able to back up. And again, the backup took 20 seconds. Self-service, that was me. I'm not a DBA. I pressed the button, I got a backup. And we're able to create copies of that database. And the copies were quite interesting. So we create one copy for the end user, for the self-service user, myself. But then within that, I'm able to create copies of the same database. So it's the same connection string, and I've got another copy. And what I used that for was to start dropping the triggers and doing various tests on different algorithms to mask the data. And that really speeds up the process. So in that customer, the project managers or the test managers at Anguish, we actually delivered the Delphix solution into that environment. It took us some pain to get through the infrastructure team, but once that environment was delivered, these were the results. So we had a lot less anguish, but also we'd reduced the refresh cycles from those environments, those test environments, from 9 days down to 10 minutes. They no longer had lost 20% of their environments due to the refresh process. The masking SLA that they had, which was 24 hours, and it was only masking 6 email columns, that went down to, it took 3 minutes, but then we did more effective masking. And again, that was automated in the provisioning process. So there was no 24-hour delay. And because of the minimum amount of storage we were using for that database, we were able to mask out a band. So it's almost instantaneous. There was no downtime for those refresh of the environments. And with that self-service I talked about, we were able to put the Oracle database and the 2 SQL Server databases synchronized together and to bookmark and rewind those databases to a point in time. And so when that gentleman who said it was Friday afternoon, he wasn't, and the databases were out of sync, we actually pressed the button in the self-service utility, and we had all the databases in sync with the application, and he put his coat back on the rack and finished the hours test that he needed to do. The other capability as well is about moving that data very quickly. And the secret sauce within Delphix on moving data is actually not to move it at all. So we actually share pointers to blocks of data. So that allows us to provision, multi-terabytes in minutes. I mean, the fastest database I've seen move is a 95 terabyte Oracle database that we delivered in under 10 minutes. But not only that, within those databases, we can also move data from one data center to another. And again, we don't necessarily move all of the data. We provide an incremental replication. So the technology is available today, which allows us to move data incrementally. So we move everything the first time we move it, the second time we just move the changes. And that really allows you to speed up the processing. So that's sort of self-service. And so once you've simplified that access to all of the different data types on all of the clouds and on all of the operating systems, the next thing you need to do is to automate that. We provide a self-service API and wrappers around that API that make automation simple. So you can download an executable that makes it quite trivial, a single line of code to do quite interesting things. And if you look at this piece of code here, so this runs what we call our DX toolkit, and we can provision a virtual database just with that single line of code. So we're able to not only spin up ephemeral environments, ephemeral containers with the application, but we can spin up full copies of data in just a few minutes with a single line of code. And that's really quite important, because it means that you can put that data inside of your pipeline, your automated pipeline, and get to the point of automated testing, because we're automatically moving data around. And as you can see from that second line, to remove that database is just as quick. And the important thing to notice there, there's not one piece of SQL code there. So you don't have to understand the database in order to back it up, copy it, rewind it, refresh it. And that's really, really important. And not only that, those commands will run across all of the data types. And so the real key message here is to try and simplify that access to data so that the end users, whether they're testers, developers, or analysts, can actually get any data from any form synchronized and use it as they need it. Which really, by the way, also helps the actual DBAs. So if you have got DBAs working on data, you know, they also suffer from the lack of environments. I was talking to a guy the other day, and he actually was using Delphix and this self-service automation to create a second environment in order to upgrade and update the actual database. He was deploying transparent data encryption on the database, and really he didn't want to damage the dev environments, because there's a lot of developers using that environments and also a lot of testers using the test environments. So he was able to spin up his own environment and test out those new features before then delivering them into production. This is the replication code. Again, a simple line of code gets data from one place to another place incrementally and very, very quickly. So to summarize then, you know, we've got this tech giant North Star. They've got these application technology estates that allow them to move very, very quickly, and everything is automated. So all of the testing is automated, all the delivery of that code is automated, and that allows them to move at internet scale. And if we want to compete with those technology giants, we need to operate like them and get testing very, very quickly. In order to do that, we need to get data very, very quickly into those environments. And as I said, most companies can automate their infrastructure. Many of them have automated much of the dev test CI/CD pipeline. But now with a programmable data infrastructure or a programmable data service, companies can automate the last mile data